Well, it's been a minute since I have done a live stream, but I am set up on my bench here to do some assembly of circuit boards. These are lithium-ion management battery boards. I've got 5 of them because each breakout board is its own IC, and I'll go more in depth on that in a minute. And this should keep me busy for a little while. So let's switch my camera to an overhead view. I'm just going to move the chat box over just in case. Stream health. It's working. What did I do with my chat? Lost my chat. Where's my chat window? There it is. Okay. Ba, 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 ba. And let's get some background music going. I think my audio got switched. Every time I plug that microphone in, it likes to switch my audio source. There we go. Okay. Let me just pull up that. Okay. So, these are the 5 circuit boards I have. I think my audio might be clipping a little. But these are the 5 circuit boards that I have. The easiest one to assemble would actually be this one. Just a couple pin headers, an IDC, and a screw terminal. And then the battery holder fits in there. I am still waiting for the battery holders. They should arrive in a few days. But these are the various holders that I picked up from AliExpress because they were cheap. A fair bit cheaper than the ones from DigiKey and Mouser, but they also offered this 4S size, and I think there was a larger one available, but I only bought the single size all the way up to 4S size. The actual project I'm building these for will end up being a 2S battery assembly. But these boards here allow you to test from 2S all the way up to 4S. I think the charger IC is actually capable of 1 to 5S, but obviously in my setup I'm only doing 2 to 4, so... So I'm actually waiting for more of these, so this is my sample for making sure that things fit correctly, which in this case I did get my footprint right, which is nice because this is actually a slightly different size than most that you find online. I do like that they have screw holes here, makes it both good for possible mounting options, but also just the strength of putting it on the circuit board. Some of them only come with nubs to help align it, and then you're just relying on all the solder joints to keep it in place. this style that has the open window, I find is nicer if you want to try and get cells in and out. Other styles of these can be next to impossible to get a circuit board out, a cell out without ruining the jacket on it. The pins on the side are for bypassing cells. So on the back of the board, kind of gives you an idea of what the wiring order ends up being. Because if you're doing 2S, then you just got 2 cells, but if you're doing 3S, then it's like 1, 2, 3. Because it eliminates tracks. It just makes it nicer so that you're not doing like 1, 2, 3 cells or 1, 2, 3, 4 cells. The way I've set it up allows for nicer tracks to just go direct to everything. I'm gonna wait to do this one because it's only THT soldering, and I'd rather get some of the stenciling done today. And then I'll fire up my soldering iron later and do THT soldering. The other boards that we have an MCU board, which is an ESP32, a header to hold TFT screens. I have a bunch of these on the way. Now, I'm not actually using this specific screen. The screen I will be using is actually this one. They are almost the same size, I believe. So this one is slightly larger, but the bonus is they are the same height. This one does have rounded edges, and you lose, I think, like 10 pixels in the corner because of that. But this is an updated driver, and you get slightly more screen real estate, but it is a nice screen. They both are, but they don't like being on long ends of wires running on SPI, which is an interesting thing to learn in a project. I'm waiting for more of those to arrive for this project. And then the other connection point is for NRF24 radios, and these actually just arrived today. So for the project, potentially have to use these for some custom barcode scanners that I'm building. Potentially this is going to be their method of communication. I'm trying to work with the client to see if Wi-Fi is an acceptable option. I would prefer it. It'd make the code easier. I think it's easier to manage, easier to upgrade. But if not, then this will be the other option. So I've made spots for pin headers. I'm not soldering these directly. I'll put pin headers so that I can plop these into place. Remove them if necessary. But I did that so that I can test how I want to send the packets, because you're limited to 32 bytes, I think, with the NRF. The bonus of NRF, and the reason I chose them... Oh, hey, Johnny. Is because you can change the acknowledgement payload. So I can save myself constantly switching between reading and writing to the NRF. Especially if the scanner is idle, I can simply just attach a payload with basic telemetry information that, yes, I received it. Here's my battery information. I'm currently sitting idle, or I'm currently have a user logged in, or whatever. Next board here to assemble is a USB-C power delivery sync controller. So this is an IC that should communicate with a USB-C charger to select a voltage that you've required out of it. It is controllable through I2C, which the MCU board actually has 4 connections for. I'll end up using 3 of them, and then 1 is a spare if I want to test anything else. I do have USB-C but a 2.0 socket being used to program the MCU. Fairly straightforward. You got MOSFETs for turning on power, and because it has to, I think that's it. I think it's mainly just turning on power. But you do get GPIO options with this IC that you can control. Then you have a 2 to 4S BMS board. IDC connection is for the MCU or the battery board, and that gives you the cell taps so that you can monitor individual cell voltages. This also has the ability for external temp control, and it could do cell balancing. That was one of the big things with this, was getting a board that is capable of doing cell balancing for proper overall battery health. Also have an I2C uplink, current sense resistors, a whole whack of capacitors for everything. I also have 2 sets of pin headers here, and those are for the 2 sets of MOSFETs. One of these MOSFET footprints is absurdly small, but it's supposed to be very capable of in its current handling. So I'm hoping it works nicely. If it does, it will be good, because that's less board real estate I can use when building a barcode scanner, and it's something that has to be potentially quite small. Granted, yes, these boards are larger, but I did that because there's a lot of probe points on these boards, as well as it's just nicer and easier to work with a larger board, which you can do with a breakout. But a lot of the core parts are actually kind of small. Now I mostly work with 0603, but I'm sure if I needed to, I could go to 0402 when I actually design my production board. And then the last board I have to assemble is a charger IC. So you got battery connections, you got your system connections. So this should be capable of both charging the battery and letting you continue to use your device at the same time. You got your input connections, and all these boards are set up so that I can run cables easily between them all, and I don't need anything extra to power anything or connect anything. It also has its I2C connection, a really big inductor, because it can do boost and step down. And you got a selector here for the type of battery you're charging, and this one has an absolutely absurd number of capacitors all over it, so that's going to be a fun one to assemble. Now the thing I do with my boards, and I know some people don't like it, but I tend to favor putting the value of something rather than putting the designator. Now I do have a few designators on here just because the part is the same and there's nothing really unique, but like a lot of these capacitors, I put the value because I find it easier, especially when I'm assembling. I don't have to constantly look at my screen to know that I need to adjust stuff. I'm just wondering, is my camera out of focus again? It's a little out of focus. So the autofocus tends to adjust too much, so I tend to leave it off. Yeah, if I was doing something where I really needed the real estate, I'd probably leave them off entirely, but when I'm hand assembling it on my own, it's easier to just have the value. Now, granted, I pretty much always open source my stuff, but if larger manufacturers would stop rubbing off IC names, and of course, granted, that assumes that the IC is readily available, that'd be nice too. I think this is the one I'm going to start with. Let's see, ESP32, you got a few capacitors, diodes, LEDs. I think the fun one is going to be making sure the USB-C gets good solder paste on it. Everything else is fairly straightforward, larger parts. I did go through and make sure that I have all my parts sorted so that I don't have to go looking for stuff. Need 4 of these. Let's see. Parts. Gonna need capacitors. Right. Let's see. 10K. Yeah, I've been working on these boards for a little while. Had somebody else. We're going through data sheets like nothing. They're almost entirely based off of the reference schematics. Which some of the stuff they put in their references are kind of interesting to say the least. Partway through, I think it was the BMS IC, partway through, the one we were going to use finally showed up as not recommended for new designs, and the IC they recommend to replace it is not compatible at all. We need 2 to 4S for testing, and it was a 3 to 5S IC. And I'm like, that's not going to work. So I spent forever trying to find alternatives. And I think I found one that will work nicely and has good functionality. We're also trying to find ICs that had good enough documentation that I'll be able to write the I2C libraries for them. Because I've tried doing that with some ICs in the past, and it's just, they give you the raw data, and then if you get anything that, like the one that drove me nuts as I was looking at the 125 kilohertz wake-up ICs they use in car key fobs, and the only code I could get was for a PIC, and it was, I think most of it was machine language. It was horrendous trying to read it, and I pretty much gave up, and I still kind of need that project, but I'm thinking I can cheat and use BLE instead, when an ESP, and I think it will more than meet my needs. But those LEDs that I end up using on this circuit board. Green. Need the programmer, capacitors, diodes, buttons, Another diode. Ah, need an ESP32. I did not label those diodes. Let's open up KiCad. There's data line protection diodes. I have definitely not regretted switching to KiCad from Eagle. It's a million times easier to use, that's for sure. There's my USB. One of these days I'll use the overhead bins I have and actually sort stuff and... I forget the person's name, but they've designed those 3D printable SMD magazines. Those would be super handy to have those. Oh, inductors. Oh, no, dropped stuff on the floor now. Got a absolutely large new workbench, and I have stuff all over it. Yeah, let's build a large workbench. It'll give me plenty of space to put things. Instead turns into an extra large dumping ground. And I actually finish half my projects. SMT magazine. These ones. If I'm not mistaken, Robin's actually working on doing injection molded ones. Ah, there's those diodes. What else? I really wanted to get one of those pumps, but didn't have the budget for it. Maybe down the line. Oh, there they are. I was looking for the other set of LEDs I needed. I have two different colored LEDs so that you can see where power is being injected from. Still missing the LM regulator, I think. Shouldn't be hard to miss it. Pretty large. Oh, there it is. Yeah, I'm not actually sure how much I would use it. I think I would use it, but honestly, I use tweezers so much that maybe not. But never really know unless you try to use it, I guess. Although I really do need to get more tweezers. These are actually good tweezers. These are the spoke phone ones that I got a while ago. I had some other ones that were similar but cheaper. Honestly, they're great. I've started bending the ends of it, so I kind of need new ones. That's what I get for using them on stuff that I shouldn't be, and I end up damaging them. But for the most part, they're great. I like them. I think I have all the parts I need. Let's get the stencil. That's the right one. Working on any fun projects lately, Johnny? I think I have everything. I need the crystal. That's what I'm missing. Yeah. Crystal. Where is the crystal? I think I need, maybe I have the 1 UF. Do I have the 10 UF already out? That's a good way to do it. I've actually finished most of my current to-do tasks. My ongoing one is designing and building myself a new e-trike, but that one's budget limited, so it's gonna take a while. Probably one of my next tasks all in the springtime when it's a little warmer to be outside, because my garage is unheated. I will go out and start taking apart the old one. I want to properly weigh it, so I gotta get myself a couple extra scales so that I can stick a scale under each of the wheels. So 3 scales. Thankfully they're only like $20 on Amazon. And then as I take everything off, I want to individually weigh things. Part of the reason for building a new one is battery is currently dead, and to replace it is a good chunk of money. But my government created new rules that would potentially make the thing illegal, but they've been sitting on the rules for a while, and I'd rather not end up with a big paperweight. So I'm going to design a new one that could try and meet those new rules if they ever decide to use them. And if anything, it would actually just make the thing more efficient, because I'd be losing about 50 kilos worth of weight. But I want to take everything off it. There's some things I realized I didn't need to do, or I could have done differently, so obviously I learned from that. So as I take things off, I can kind of get a real understanding of how much everything weighed on it, and then try and figure out how I could meet the next rule. If I went with the battery I want to use, I'd have to somehow make the next one weigh 30 kilos, which would be interesting to say the least. Considering I want it to be fully enclosed, I do want it to be like an aluminum frame to try and save weight, but also do the canopy and carbon fiber. USB switching. Yeah, I still have this on my desk. This thing is great. I love using this. I've been wanting to do the next version of this with power delivery and whatnot, but it takes time. Especially this. This took me like 3 months of programming. That was a programming task and a half. Granted, this current project is going to be a nightmare. Granted, it's a paid project, and it's a project I'm very excited to be working on, so no love lost there. Trying to think the best way to hold this. The fun one to get paste for is going to be the USB socket. It's going to be the most critical to have good paste on it. Although I've had good luck lately with pasting. Did a small QFN the other day, and it soldered like nothing. Actually, I've had better luck with QFN than QFP. It's so weird. Let's see how I did. I think I did terrible. I've actually found I have better luck with a small stencil. I used to do a larger stencil, but I've had good luck with smaller stencils. Can't tell if I actually got enough. I think I did. Slightly off center, but I think it will reflow. It has enough paste on it, but yeah, this is 60 by 100. Thankfully, most of the hardware I want to use for this project I'm familiar with. So the only real test circuit boards I'm using are these battery management ones. And then everything else I have. I actually have a T962 oven that's slightly off camera that way. I bought that in college, and it was the best $200 I ever spent. And I think every single one of these boards actually managed to make it a 2-layer board. I was kind of impressed. Granted, these things are absolutely massive boards, so... Although nowadays you can get 6-layer boards at a really good price. It's amazing how much things have changed over the years. For the most part, I've had decent heating. I know there are hot spots in my oven, so depending on size of boards and how many I'm doing, I have to kind of pay attention to it. But for the most part, it works fairly good. I really want to change out like fans and stuff in them. But overall, I've been happy enough with it. Well, I'm just realizing this 10K resistor is missing solder paste. Might get away with putting a dab on it. If not, I can just manually solder after. Got 1, 2, 3, 4, 5. Yeah, I got 5 of them. Thought I had 5. 1, 2, 3, 4. Ah, missed one. Yeah, I probably should have done the solder paste again on this. Oh well. I've only recently started doing 4-layer stuff, but it's handy. If I have to do stuff in small areas, it's really handy. 2 of these. Oh, I don't think I actually ever found that crystal. I need to go back into the box and look for it. Although I know I'm missing one of my resistors. Ben, hello? Oh, this one's in a tube. If you wanted to add the PoE auto switching to something like the Rack 32, I have a feeling it would be a board revision. I didn't really design mine to be incorporated into a project. I designed it as a breakout and a test assembly so that you could understand the design principles behind it. Although I have had a few people ask about me potentially designing it with onboard Ethernet IC built right into it, so it could be a drop-in board that somebody could interface with and not have to do any PoE stuff. It just does it for them. But as soon as John gets the board, I'll open source my files. Till then, I'm kind of keeping them hidden. Not for any particular good reason, though. It does work. I've tested it thoroughly. It went through 3 revisions. Well, I like where it ended up because I find it's reliable and the components used are fairly small, that it wouldn't be hard to integrate it into something and not have to worry too much about screen real estate. It might not be next week. Still waiting for it to land in Australia. Shipping's gonna probably take a couple weeks. Me too, because that package actually has extra goodies in it. Lots of fun stuff to be explored. Ooh, nice. That fit nicely. Granted, I've tested these footprints, but it's nice that they're actually working. Probably helps that this particular USB-C is 2.0 compatible, not your full 3.0. Didn't need 3.0 compatibility. Would have been interesting to say the least to do 3.0. This one, USB hub, I still have it. It looks great. I know on and off, well, only once have I actually seen the IC come back in stock with the chip getting going on. But I haven't really had any orders for it. I've wanted to do the third version for a while, but it's cost and time. And most of my year is going to be held up doing this project. Because it's a very large project, but a fun one. How many of these? 1, 2, 3. That's it, I think. 1, 2, 3. I'll keep that in mind. Next time that I know they're available, I'll try and put it out on channels and see. Granted, it really needs a code update. Still works, just I've learned a lot since I last made them, and it could use an update. I want to get some paste for that. I wish I had paste in a syringe. It'd be really handy for spots that I miss. Fun part is actually getting it to want to stick. That should do with it. And oh, that was just to go. Did I accidentally move it? Whoops. Let's grab another one. Oh, I think I need one more. I need one more there. Oh, come on. Nope. There we go. All right. There we go. What else am I missing? There's no marking on that. Why do they have to make the marking so dull? My goodness. I can go there. And capacitor. Yeah, no worries, Ben. I'll be here for a little while at least. Goodness knows my live streams tend to go long. I'd initially planned on doing it sooner, but things get in the way. Part of the reason I like doing these is it's a good way to keep myself focused, and I like being able to show that things tend to take time to do. That's why it costs so much. Thanks, Aaron. Yeah, it's I bought a spare webcam on sale the other month, so that I can put it above my desk. I'll take that as a compliment. I am slowly trying to improve what I can do so that things look nicer. My last video, I even had my UT61E working. Oh, I do need that other colored LED. I had a feeling I was using it somewhere. Well, there's a few parts I gotta go find in the bin. Got that, got that. Ah, there they are. Let's see, missing diodes for there. Oh, missing 2 resistors up there. One, 2. Oh gosh. That sucks, Johnny. Right, that. Really should have kept myself organized so I know which ones I've used and haven't used. Oh, I always hate starting a reel. Well, it's not even a reel, it's a piece of a reel. Getting under the tape to get the first few parts out without having them spill all over the place is annoying. Oh, this one doesn't have a marking underneath. Of course it doesn't. Semi-retired. Ooh. I guess you wouldn't want to know that I just turned 28 then. Like the other week. Nope. Let's go to multi. Diode function. Nope. No. I think. Let's see. Yeah, there we go. So that's positive. Thank you, Aaron. Nope. Okay. Goes like that. Let's get it in place before I forget. And yes, I realize the silk screen says red when this is a yellow LED. And the reason for that is JLC's Surface PCB-A has green, yellow, and blue as basic LEDs in the 0603 range. So I picked those. Initially I was going to have JLC assemble the MCU for me, but it's like an extra $100, so I figured, might as well self-assemble myself. It's not that difficult of a board. Sometimes the cost is better, and it's just nicer to get them to do it for you. These are the diodes that I'm missing. I can't remember. Are these bidirectional? I think they are. Yeah, they are. Woohoo! Good. I don't have to figure out what direction they're supposed to go. These are for protecting the data line on the USB port. Almost forgot them in my initial design. And that leaves the crystal. I'm missing 2 resistors and an LED. Right. LED is... That's the LED. That is the crystal. Give me a minute, Aaron. I can explain that. 33, 30, betting it's in the other box. Yeah, I think it's in my other box here. Hope it's not in my under storage. Pretty sure I grabbed it. I think my YouTube playlist is ending. Yep. Time to find a new one. This one's 4 hours? Yeah, that should do the trick. Not in that box. Should be. Nope. That might get off my list, or did I forget it on the list? No, I don't normally... I like audiobooks, but I don't normally use them, no. At least not for a while. Actually, the trick I used in college is I put... I had accessibility requirements, so I was able to get a PDF version of my textbook, and I could use it in a text-to-speech software. Yeah, it's missing on my list. That's why I didn't grab it. Missing a 4.7K resistor. And on my parts list, it's missing. So, under the desk I go. Okay, there we go. Thankfully I knew where it was. Ooh, I'm gonna turn my fan on. It's getting warm in here already. My room gets way too warm way too quickly. And the wall that's behind me, that separates from the bedroom next to me, I put sound foam in it. And while it cut the noise out a lot, it has the unfortunate side effect of making it even warmer in here. On top of me running my thing. I can almost never fall asleep to music and stuff. I use my fan as white noise, or I have a child's music album that I've listened to for years. Obviously, first started listening to it when I was a child. I only ever listen to it when I'm having severe trouble sleeping. So that's the crystal. LED. And 2 resistors, and that should be it. Now, does this one have a marking on it? Yeah, it does. Should go this way. And then 2 resistors. And once I put this in the oven, I can give a recap of what I'm working on. Ooh. Yeah, buying this silicone mat was a great choice. It's so much nicer to not have stuff moving around and you can see everything. I haven't even finished putting all my LED lights in and hooking them up to my controller, and it's been quite effective. But that is all the parts. Let's just fix this connector. Should be good to go. It's 7 minutes. That's how long the oven takes. So I have these boards and that board. And the board that's currently in the oven has an ESP32 on it, and it is the control board that plugs into these over I2C, and they as a group are for connecting to this board, which holds what is it, lithium batteries. I'm actually still waiting for more of these sockets, but this was one of the samples I bought. Bought everything from 1 to 4S sockets. But the project I'm using all of this in will end up being 2 cells in series. This whole setup allows you to test from 2 to 4S. There's jumpers in place both on this battery board as well as the BMS board that it plugs into over IDC connection, and your main power trunk is through screw terminals. Yes, 18650s. Although, granted, with voltage levels, you could go to 2170s and 2171s, I think. If you wanted to, you just need a different board to hold the cells in. But in this case, I am using 18650s. And so these boards are simply for testing the various ICs and functions. And my idea is to, for the project I'm working on, I'm building custom barcode scanners because I'm building a custom inventory management ecosystem for a non-profit, and they have unique inventory challenges. So I'm designing a ground-up solution that specifically meets their needs. The only board I don't think I'll actually end up using in the final design is the USB-C power delivery board. The only reason for that is because for charging, for ease of use, it's probably just easier for me to use a 12-volt charger, well, 12-volt power supply, because where I'm building the system, there'll already be power available. Because the second half of the project is building a gift code ATM machine for sorting and managing gift code donations. So I'll be building a machine for that. So I'll have power supplies in it, so I can just eliminate having this control system and just directly power the charger board off 12 volts, which should be allowable. The charger is boost and step down capable. The reference design uses the world's most absurd number of capacitors, but they're there. Yeah, it's hopefully, fingers crossed, they all work. The fun part is going to be setting up the libraries for everything to communicate and be able to change settings for the I2C connection. But let's see. I'm not going to use my sample. Expecting more parts. Let's see. Yeah, there's holders, I think, just past customs. So probably get it within a few days. Yeah, it just passed customs. I should get it within a few days. Woo! Welcome, Aaron. Hopefully I wasn't rambling too much and I actually explained it. Ooh, parts. What parts do I need? Might as well do some THT solder when those come out of the oven. The MCU board needs it. Cool. Just pulling out an extra board. See what parts I need. And let's put a bunch of these parts back in the box. I already got all the power cables cut and terminated with ferrules, so those are ready to go. Need IDC screw terminals. Pin headers are my overhead bin. They are here. 1, 2. Can't remember if I was going to use female or male there. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Ah, I can use both. How about use female, because I don't actually expect I'm going to use that header. One, two, three. The cabinet is mostly done. I have it set up that I can put the LED strips in place. The final side panel is finally in place. The holdback is me sanding the drywall inside of it and painting it. I have the doors glued up and ready to go. I have to cut them to final size. But that's sanding, and especially sanding small corners in a tight box. I'm fairly certain I chose like the worst method of construction to build the thing, but I wanted something that would look nice and it should block a lot of sound out, so that it's not disturbing anyone in the house, as well as I can easily live stream the printer doing projects. At least that's the plan, is to have it do some live streaming. But I need to finish putting the thing together, and I would like to get the Pusher Bear upgrade in my printer to make it look nicer and get it ready for that kind of stuff, but in due time, I'm sure. But that, I still need that, and I need that one as well. I think that's another box. That's 6-pin. That was my 4-pin. Sometimes it's motivation, other times it's just distracted by other projects. But this upcoming project is so large that I want to film a fair amount of it, which is why I'm trying to get things in place to better do filming and live streaming. The fun part of this project will be learning how to use FreeCAD. Because I need to do 3D modeling, and I'm not paying $800 for Fusion 360. I think the only thing missing are the sockets. Oh, I need the IDC as well. IDC. I grabbed them. Just a matter of where I put them. Let's see. That's 6-pin. And that's the oven. I think that's yeah, the few times I've tried using FreeCAD, I've gotten really annoyed with it. So I've mostly just been nitpicking at it, doing certain tasks. But I need to properly learn how to use it, so I'm missing these sockets. Yeah, so that's my plan, is that I'm just gonna start from the absolute basics and learn how to use it from the ground up. I think it's the only way I'm going to learn how to use it properly. I actually need 2 of these. I might as well assemble them now, considering the THT parts, and it's just going to be easier. So the only thing missing are these 2, and see, I love Fusion as well. I first started using Autodesk in high school, and yeah, I've been on an education license for like 13 years, and then it finally expired, and I can't justify making 10 grand a year and spending $800 on a Fusion 360 license. It's just not going to happen. Honestly, I never fully used the Eagle integration. I always just used Eagle standalone, but I really hated when they started switching everything to cloud-based. So I've always disliked that aspect. Especially if you go in and look at, yeah. Well, see, I'm doing commercial work, so the free tier doesn't really work very well for me when I'm doing commercial work. Oh, I switched to KiCad. I am loving it way more. But that... How did that solder? Oh, I don't think it properly soldered the data pins. Gonna have to take a closer look at that. As far as I understand, the free version, you're not supposed to do anything commercial with it. At least with Fusion 360. I don't know if that's different for the Eagle free. Let's see. Yeah, so I'm gonna go try and see if I can find these. I think I know where they are in my parts collection. Yeah, so unfortunately I am not, I'm old, my business is older than 3 years, and I've already tried emailing them to see if they would exempt it, and they said no. And annual revenue, borderline, the $1,000 mark. It depends how much you want to dig into all expenses. So not worth arguing semantics with a company that decided to destroy their best product line. Looks like I didn't get enough solder paste on some of those pins. Oh, I normally do with my time. Right. I could. Let me see if I can pull up my order history, because I'm certain on my last order that I put an order in for those. And plus, the more I try to do semantics and try to use Fusion 360, then the more dependent I end up on it. Whereas if I just rip the band-aid off and try to learn FreeCAD, then I can probably move on and be fine with things. Let's see. Yeah, I did order them. Okay, so they should be in this box. Yeah, what do you know? There it is. But the other thing I wanted to do is set this up. For this specific one, I'm using the 32E because it's the latest recommended one for the basic ESP32 lineup. In the actual barcode scanners, I'm going to be very likely using an S3, but I want to find one with 16 megabit and the 8 megabit PS RAM, which the new this one here, the WT32 Plus is using, well, the ones that I have ordered are 16 megabits. This one is 8 for whatever reason, even though it's supposed to be 16. But they've limited these to all 2 megabit PS RAM, which I was like, that's annoying. So to make sure that my project has no hiccups, I will be changing that out. But I'm actually going to change the whole circuit board, both to save space in the barcode scanners, but also to make better use of the I/O available, because those only have 6 I/O on them, and I kind of need more I/O. But I want to use those because the screens just look phenomenal, and I want this product to look as good as it can look. I need USB cable. Let's see if I can make this work. Settings and okay, That'll work. So, should have set this up ahead of time, but I didn't think to add it. Oh, what do you know? That actually looks like it's soldered. Is it? No, maybe not. No, it's not. That base was too misaligned. But I bet you I can run my iron across it and get it to work. But it also looks like I got a few bridges on that. So, grab my tweezers here. I have not done any Zigbee boards. Hopefully that's showing up okay. Looks like it. Yeah, so if I look... So the really annoying thing with this USB microscope camera is that when it's in PC mode, it no longer lets me use the screen attached to it. It's a good device, but doesn't let me use the screen. So a lot of this paste was misaligned from the pins, so it didn't actually reflow it. But I'm thinking a little bit of flux and my iron, and I can get it to work. But I do have a few bridges on the end contacts that I will have to fix. Depending what you're doing with the PWM control, Johnny, you might want to look at a PWM library I've done. It's designed for LED control, but it's really nice, especially if you're mixing color channels, because it does everything mathematically. So it gives a really nice transition. So, let's see. I can't move myself over here. Now, I have tape on this because I was using it for a demonstration and didn't want to short circuit the device I was showing under it, because I essentially used it as an overhead projector. Remember those things? Ooh. Let's see. How do these pins look? Could have used a little more paste, but they don't look too bad. I think it'll work. But the big thing in question is... What is it? Is that USB port? Let's see. I have flux somewhere around here. At least I usually do. Oh, there it is. And get my soldering iron. think I bridged that even more, didn't I? Yeah, I did. I have a sneaking suspicion I'm gonna have to hot air this. Pull it off completely and clean the pads. Oh, color me shocked. Let's make a new standard and it's gonna work. As if. That's why I like designing my own stuff and using my own firmware. Let's hot air this. I have not used Zigbee yet. I would like to get like door sensors and stuff. And I know, so I have electronic locks in the house on doors that are keypad, and I've been wanting to hack them with a new control board because then I can monitor battery life as well as remotely update passwords. Because right now I have to go around to like 4 different keypads and update passwords every time somebody moves. And it'd be a lot easier from a management standpoint to just go to a... so I have the Oxy's touch panel. I could just go to a touch panel and put it in programming mode and change the code. It'd be very nice and handy. Come on. There we go. Trying not to burn this connector. I think that came off nicely. Let's see. Yeah. I can touch up those pins a little. Make sure they have enough solder on them. So I have really good Wi-Fi, which is why I've mostly used Wi-Fi, just because I have it, it's implemented, and I know it's reliable enough. But I could see myself using... Now, I know the only panel I wouldn't be able to hack would be our front door one, but that one is supposed to be, I think, Z-Wave enabled. But from what I understand, it's a really terrible setup. But I'm still tempted to get an adapter for it so that I can see how bad their implementation is. Yeah, if I ever do motorized blinds, I am going to make them custom myself, because it seems to be a product many people have had issues with. And then the other one I want to do is get some resistive pads. They're relatively cheap, I just haven't bought them. And set up a grid underneath my mattress so that I could know when someone's sleeping or lying down and trigger lighting based on it. Let's see. Need to clean up those pads. Did those pads fill in with copper? Kinda looks like they did. Oh no, they're through holes. Does this connector actually have... Oh yeah, it does have nubs on them. Let's get a better view of that. And let's clean that up. Oh, don't need any solder bridges. Clean off my soldering iron. Let's see if I can't clean that up a little bit. Should do the trick. Does this microscope look okay on camera? Like, it looks okay from my end, but I'm curious if it's actually worthy of me showing it. Cool. As I said, I'm trying to up my game on uploading stuff. Really annoyed that YouTube got rid of their audio tools. The last video I posted, I had to take it down and re-upload it because the audio was really quiet. Combination of Windows auto-adjusting volume every time I plug my microphone in, and the program just being weird. Because I didn't adjust any settings, but I bet Windows adjusted stuff. Have you guys seen the new air quality sensor that IKEA is dropping in April? Looks like it's going to go through the hub, which I think is Zigbee. But it's supposed to be able to auto-control their air filters. Ramp up the fan speed as needed. I can't tell if I've actually flowed this or not. Of feeling the base plate is acting as a heatsink. Yeah. Was indeed acting as a base plate. Or a heatsink, I should say. I think I got that soldered now. Wondering about that pin there. Well, that pin didn't get soldered. You're talking about this, Aaron? Because this can be powered off battery and USB for programming. Although, yes, ideally you're doing this on battery. But I'm certain I bent that pin. Oh. There we go. Yeah, I bent that pin, but I think it's soldered. Oh. that isn't soldered. Let's see. Let's see if I can't. Yeah. That just bridge. I think it did. Ooh. I think it did it. Oh no. Tip. Nope. Oh, come on. Oh, no. Off you come. Oh. No, still got a small budge. Come on. Let's try adding more flux. Oh, I hope I didn't ruin that trace there too. There we go. See, this is something I've been finding more and more on GLC's boards, is the solder mask on some traces fails way more easier than you think it should. Thankfully, I still leave a fair amount of clearance on my traces. I don't usually end up with problems. That's not bridged, I don't think. I think I'm safe on that pin, even though it is slightly bent. Everything else is soldered. Okay. Only thing left would be to do those pins. Okay. You know what? I'm not gonna solder those sockets until I test the board. So let's solder this. I actually got that one pretty good. Oh, I hate listening to the fan on the oven, even with headphones on. Granted, I don't have my music turned up very loud. There's one board assembled. That's that assembled. Yes, I'm gonna do a smoke test on the MCU board in a moment, before I fully solder down the tabs on that USB connector. But there is no active firmware for making all these boards work yet. Kind of wanted to have them to test them. First full test, I'm still waiting on the cables for the I2C that I ordered for these boards, because I ordered some really long ones, just so that everything can plug in nicely and not have to worry about them. Potentially make like a backup board to hold them all, because they all have mounting spots in the corners of the boards. But I'm waiting for those cables. But the first test would be like an I2C scanning test, to see if we can actually find the ICs. Hopefully there are no conflicts. The ICs chosen have good reference documents, which is what most of the circuits are based off of, with some minor changes. Honestly, there's a lot of things if you're going to use it in production, there's so many things you can change. They have a lot of ESD protection on them, which obviously is a reference schematic. Somebody's going to be testing it on a bench and poking at it. You kind of want that protection, but if you're building it into a device, you're kind of expecting that it's just staying static and not being hot swapped or anything. Or like the power filtering. Take this board, for example. Like, it's got banks of 0302 capacitors and 0603 capacitors, both on the input and outputs. Like, I understand keeping a stable supply, but at the same time, like, it's how many 10 UF capacitors do you need? Like, there's 20 of them on this board. Like, it's absolutely ridiculous. So some of it can be cut down and made nicer. These traces are also like super small. I think they're like 8 mils. It's very small. Right. Need a USB cable, and I need to see if it will recognize that it's plugged in. It should show up as a comms port. I'm not too sure. Typically, you use different both different sized and different types of capacitors for different types of filtering. So you're targeting specific transients and different spikes. So, for example, they've got big polarized tantalum capacitors that are larger. So that's for your big power drops that you immediately want to try and bring it back up to voltage. Especially for this, where it's a charger and it's controlling an inductor and trying to maintain a certain level, because this can do both boost and step down control. So they want to maintain that level voltage supply when trying to charge a battery. And this particular IC is set up so that it has both a battery connection and your system connection. So it can monitor power going both into your battery, but also power that's going out to your device. So it's trying to maintain that stable voltage while it's in operation. And then your smaller caps are trying to filter any noise from its boosting circuitry. At least that would be my understanding of this particular circuit. It also has a resistor connected to one, so then it's trying to filter in any noise coming from the incoming power supply. as a noise filtering thing. So yeah, but let's see if this works, and then I can finish soldering this USB connector. So I just heard my computer. The yellow light is on. So there's 5 volts coming in. The blue light is on, which means I have 3.3 volts on the rail. And it's flagged an issue. Device cannot start. Why not? So it's potentially a power issue, something like this. So let's see what it says. Oh, it says it's a driver issue. That doesn't make sense. So either means I don't have this port fully soldered correctly. Now I'm missing 2 resistors here that are supposed to be for setting the current. Because see, this is the same setup, just I'm not using the 5 volt line. And I'm fairly certain it powers up properly once I give it 12 volts. No, it throws the same error. Windows did an update recently, and it seems like Windows decided to block my driver. Let's have something to drink. So, show you what I'm looking at. This is the currently plugged in LED driver, and it's showing an error for the CH340, and it was not showing that last week because I just got these boards in and I tested them. Initially somebody had purchased them or wanted to purchase them, and I was going to wait till I did a crowdfund campaign for Oxers to sell them, but I wanted to make sure they work. Because this design was a complete change from what it initially was, which was a D1 Mini, I changed it so that it's easier to produce and assemble and whatnot, because I'm using an assembly service. But then the person has ghosted me, so now I'm left with inventory that I need to sell at some point. Yes, in my last order, I also had these delivered. I ordered some of those USB cable testers, so I know this cable is good. But I need to figure out why the driver has stopped working, and I know Windows did an update the other night, so it has to be that because this was working. Search 340 driver. Which driver does it show on this? Properties. Driver. It shows the right driver. Oh no, it's showing an older one. Well, let's got a Mac. Ugh. No thank you. Absolutely not. My plan is actually to eventually go to Linux. Hey, Ben! Woo! Oh, it's still throwing that error. Properties. And it's showing the old one. Windows found drivers but encountered an error while trying to install them. Huh. So it has drivers, but it's not installing. Well, that's annoying. Hope it's not gonna make me restart the thing. Oh, see you later, Johnny. Thanks for coming and keeping me company for a while. Properties. Port setting. Driver. Update driver. Browse my computer. Browse. Download. Okay. Next. So I think the best driver is already installed. Oh yeah, I have my juice here that I've been sipping on from time to time. Right. So why is it complaining? have a feeling I'm gonna need to reboot my computer before it works, which is annoying. I guess for craps and giggles, I can try flipping the port. Well, it still shows the same error. Trying to install Intel's driver support assistant because it's supposed to be able to auto find drivers for your motherboard and such. It's apparently adding USB 3 or USB 2 drivers fixes this error. Oh, computer must be started to finish the installation. Of course. Oh, that's lovely. Yes, I can do that in a second. Let's try uninstalling. Let's try it again. No, it's saying code 10. Requires further installation. Another cable, right. I know I have an absurd number of these cables lying around. I know some cables are. Yeah, I have a large number of these cables. They pretty much send a new one every time I order a display. Nope, that does the same here. Ooh, that's a tight connection. Come on, out you come. There we go. What I do have is a different extension cable. Let's plug that in. Let's plug it into my rack. Find the port under my desk. There we go, and let's see. Hey, that worked! Okay, so it's, something went wrong with my USB hub. Weird. So the USB hub that I was trying to plug into seems to have an issue. But that did just get recognized. Yeah. So part of my desk building is I've been meaning to build so I have a center post column. I think you can see it if I move the camera. So there's a post column right here, and I've been meaning to build like both an AUX's button panel, the touch display, and then I want Ethernet and USB ports, and then something like a smart hub available as well. Just that I have everything easily accessible and pluggable into. But everything takes time to implement. But I have a USB port on my rack that I plugged this extension cable into. And that seems to work. So that is connected. Let's see if this will recognize. That was not recognized. So I either have to fix the soldering, there's something else wrong with it. It was recognizing it before. There we go. It found it. So, what can I do to verify that works? I think the easiest thing is going to be Arduino. Oh, it's cold as cold. It's definitely not getting warm, so all is good there. Would rather not like lead and what do you call it? Flux. But let's see here. File open. I have, where is it? Nope. Here it is. So, this is a sketch for Scanning an I2C bus, 22. So SDA is 21. And 22. Tools, port, COM16. We are connected to ESP32. Oh, come on. I hate trying to do this. Am I using a rover? No, I'm using a room. Dev module. And power it down for a moment. And in my parts bins, I have this nice assembly of parts. If I switch back to overhead, I have this lead is all the various items that my sensor library for Auxers is compatible with. So I keep a set of it in my bins so that I can test things. So I'm going to plug that in. Realizing I could test each one of these ports if I wanted to, but just leave it for now. But what I do want is some jumpers. For the pull-ups. Although I don't think this is actually necessary. I'm pretty sure the pull-ups are enabled on these boards, but these are 10K pull-ups, so it won't make too much of a difference, I don't think. So that's good, that's good. We can go plug that in. Should see. Yeah, so that's all powered up. The boards are powered up, and switch back to this view. We can upload. Open serial monitor. Oh, cool. Let that finish its task and see what happens. Oh, uploading. Aha! We have a working control board. That's 1, 2, 3, 4, 5 devices found. 1, 2, 3, 4, 5 devices are connected. So that's a working control board. And if I fed power in through the VDD connection, should see this LED light up, and yeah. So, yeah. I have. Where is it? that been? Trying to remember what bin I put it in. Depends what I was last testing. Oh, there it is. That is what I was looking for. Now, what I need is a piece of wire. Let's remove a jumper. Oh, I turned my soldering iron off. Let's let that soldering iron heat up. Switch back to that. Let's unpower that circuit. Wait for my soldering iron to heat back up. Wonder which board I want to do next. I think the PD sync is going to be one of the easier ones to do, so probably do that one next. Should be the simple one to put together. I'd be curious to see if it's programmed to work right away. If it were, I'd expect it to just turn on 5 volts, but I imagine you need to tell it when to request a higher voltage. Ooh. Woohoo, it's finally here. Got more parts on the way and checking the tracking while I wait for my soldering iron to heat up. Hopefully I'll end up with quite a few packages this week, which is good. Means I can do some more testing and validating before finishing. Well, I haven't started the designs yet for my production items. Just because I think it's going to be easier and less time consuming if I'm not having to delete stuff I've already done. If I end up finding that the reference designs are not compatible for what I want. So in the barcode scanner, I'm expecting I'll get about 6 to 8 hours of runtime on the batteries I want to use. Part of the design plan is I'm going to set it up so that the microcontroller has the ability to actually turn power on and off for things inside of itself. So the items that are using higher loads, if I don't need it to be running, I'm just going to tell it to shut the power off. So a good example of that is to log into the scanners. The plan is to use the staff RFID tags, and I've bought a cheap $30 reader off AliExpress that I'm hoping is going to be compatible. I know of a company that makes a compatible reader, but their customer support has been atrocious for the past like 4 months that I've been trying to get information from them. So I decided I'm going to give this $30-40 reader off AliExpress a chance if it works. I know it's not the most ideal format to use, just based on size, although I'm hoping I can cut up its plastic housing and make it a little more compact. But the price difference will easily outweigh the benefit I'm expecting. Don't even know the cost from that main company, but their regular readers are anywhere between $120 to $300, so yeah, expensive when you can't even communicate as a company, and I just end up in a giant email thread with no answers months later. So want to give that a try first. If that works, then I'll use that. The other thing I have to test is the actual barcode scanner module. I found a module on AliExpress for $30, and that should be capable of reading pretty much everything, QR codes, all that kind of stuff. And if I can interface with it correctly, which I'm not really anticipating I'll have trouble, then I'll use that. And then your main inventory scanning will be with RFID, and I'm going to use the 13.56 megahertz tags. And I've already tested the regular PN532 readers. They can read it in milliseconds. Actually, not even milliseconds, microseconds. They're very fast at reading just the UID tag. I've tried using NDEF messages on the tags, but fastest I've gotten is 4 milliseconds, or 4,000 milliseconds. Still a little too slow, and I don't think the time spent on modifying the libraries would be worth it, when it's probably just easier to use the UID tag, and then the server can house a database of all the different tags and what they're connected to in terms of inventory. So next test here is I want to plug this back in and have it tell me, ooh, yeah, I really need to finish soldering that connector. That's way too loose. That's probably why I'm getting a bad connection to my computer. Yeah, okay. That's causing problems. I hope I haven't already screwed this connector. Oh, I have. Yeah, okay. I've ripped that connector off already. Lovely. So that needs to be resoldered again. Yeah, see, I hate that when this is in PC mode, the screen that's on it is no longer of use to me. That's a very silly thing in my opinion. Because I wanted to make sure that this worked before I soldered the side pegs. I've actually managed to break all the solder joints on it. Whoops. So let's, now that I know it can actually work, and as long as I don't see any bridges, I'm going to accept it. I'm going to solder it and then solder the side legs so that it cannot rip itself off again. put a little more flux on that. Still have stuff on my soldering iron. There we go. So those are the pins. And now I'm going to solder the lugs on it so that it should no longer break off again. Come on. There we go. What a shizzy. Oh, okay. I always thought they should come all the way through, but they don't. So I guess I just have to make sure that it's actually soldered on this side. Hold it there a little longer and hope that it's wicking to the other side. Yeah, oh, it's worked. Yeah, okay, that worked. Okay. So, should be a matter of connecting this to that and plug in USB, grab this connection. Yep, okay, that works. And then what we're testing is that I get power. Let's make sure everything's running. Serial monitor. Yeah, okay, so everything's running properly. And then if I connect this, I should see power with the green LED. And everything's still functioning. I have serial readout. So, woohoo! We're working! It's pretty cool. And if I remove USB, everything should stay running. Which, I don't have a readout, but I would assume it's still working. Yeah. I could probably load a demo sketch of my sensor library and it would show a readout on the I2C display, but we'll leave that for another day. There we go. Cool. I'm glad to know that this USB-C isn't too bad of a thing to solder. This means I can add it to more projects, because the only project I have currently that actually has it on it, well, I have other projects designed to have it, but this one actually has it. and I have it in my hands. But I ordered it with a PCBA service, so I didn't have to hand assemble it myself. But it is good to know that I'm capable of soldering that properly without much fuss. Right, screwdriver. The big thing I'm hoping is that for the barcode scanners, I'm currently trying to get permission to use Wi-Fi and to set up a secondary network for the system. But potentially that's not going to be allowed, so part of the reason I've added these sockets to this board is for these NRF modules, which this pin is bent. And I've added 2 spots for these. Because I have 5 of these boards that I can assemble, if I'm not allowed to use Wi-Fi, then I'll use the NRF24. Not the most power efficient, but they have very good range. They work well, and one of the functions I like about their code is you can set the auto-acknowledged payload. So instead of it just being okay, you can set it to whatever you want. So in the barcode scanner, what I would do is, because a lot of time it would sit idle, I would set it up so that the payload back would be battery data, like if it's charging, what its charge percentage. If it's signed in, then it would say it's logged in, but then send the login or the power stats of either how much power it's using, or if it's idle, it's just sitting there doing nothing, that kind of stuff. But I don't have to constantly switch between sending and receiving to do that. I can just do it in an auto-acknowledged payload. The other downside to these radios is the size of the payload capability is really low. Whereas with Wi-Fi, I wouldn't have that much of an issue. I think Wi-Fi would be easier to program. It'd be easier to add more to the network if you ever need more, because I'm building 4 scanners. But if I ever needed more, it's not hard to add more, whereas it would take a little bit of configuring to add more. If you're using this, you'd potentially have more issues. Oh, it's my phone company messaging me, telling me, oh, your new phone bill's ready. Because sending a phone bill at 8 o'clock at night is a great idea. The base station would actually have 2 NRF radio. I'm thinking would have 2 radios, one set to always be receiving, the other one always set to be sending, rather than having to flip-flop between them while it's trying to manage 4 different radios. I think that's the better option. It's part of the reason for designing this board is that it can act as a test board for not only testing the lithium battery stuff, but I can test these radios. And then the scanner would only have 1 radio. And I did find, so they have the power amplifier version with the antenna and whatnot, but I've actually found a version that can be surface mount soldered like a module, similar to how you solder an ESP in this format, but also has the UFL connector for an antenna. So I'll probably use that in production if I have to use the NRF. Now when designing, I have a feeling I'll still design a footprint for the NRF just to cover myself, because I don't want to have to replace a whole bunch of circuit boards if down the line there's an issue or something and we have to switch to this versus Wi-Fi or whatever. Because while I'm building it for one specific person right now, I do know there are others that are interested in what I'm working on, and they may have other requirements and so forth. So I try to make all these boards multi-purpose. And then the other part I'm still waiting for are screens. And these screens will fit there. And I do plan on using the screen for the lithium management, because you'll be able to see stats on the display. And I've set it up so that plugs in nicely. Okay, that's that one done. Battery boards are technically done once I have the actual piece to sit inside of them. And the reason I've assembled two is because eventually I'm actually making two sets of everything. I had somebody that had been also designing lithium boards at the same time as me, and I used some of their work, and I was helping them look at documentation. So I do plan to send a set of boards to them for tinkering with. Get something to drink, and let's start working on this. Put away my screwdriver. How many people are watching? What are our stats? Concurrent viewers is 4. I think I saw it at 6 at one point, which was cool. Anything interesting in the news? Ooh. Oh, looks like John's been doing some work on his oven. That actually looks nice. Earlier photos he took, it looked like a really, what do you call it? Like a cherry red almost, but the new photos on Twitter look a lot better of a red. Oh, not cherry. Oh, there's another earthquake in Turkey? Oh, gosh. That's gonna suck. Nice to hear you're still around, Ben. You're at the house doing work, or you're hanging out at home today? Actually, I'm gonna leave these two USB cables up above. Doing some work today. Oh, no, I don't want that in that bin. That's gonna go back in the closet. Let's keep that in there for now. Oh, I have not actually worked with AWS. All the things I like to mess around with, that is something I have not done. I did, I don't know if I posted screenshots of it yet on my Discord, but I managed to get, so, actually I think I did. Let me double check. Oh, I did, okay. So I had that Lenovo, and I finally got that working the other day with some help from a friend. So it's gonna be, so the gift card machine is gonna have a touch screen that will be a terminal for you to go and collect and dispense codes from. It's a touch screen, so I've managed to completely lock the crap down out of it. So when it boots up, and I checked, it boots in 40 seconds, which I think is pretty darn cool. And it auto logs into a regular user, and then within a few moments it auto starts up Firefox in a kiosk mode to a specific website that I've set. And the even if you get out of that kiosk, the desktop only has a few icons and lets you access nothing. So yeah, I think it's pretty darn secure, and you can't really access anything without plugging in a keyboard, and the only way you're going to be able to do that is by opening the machine. So, and the only way to open the machine is to have access to it. So, which is quite nice, and was a fun experiment to get working properly. I'm very much looking forward to getting the server and being able to set that up hopefully soon. It's just a matter of getting approval. Right, what parts do I need? I don't think I have a 5-pin socket to fit that. I'll probably just use pin header, or I'll leave it unpopulated. Probably going to leave it unpopulated, to be honest, because I don't plan on using the GPIO on this thing. Well, I do need the solder stencil. There's that one. The fun part with this one is the IC has a thermal pad on it, so it's going to be thankfully, this stencil looks like it has decent cutouts for the solder paste, so hopefully it flows nicely and does not overpaste. Now, the IC for that is... let's see. I'm trying to remember. Which one I need for that? What is that? Oh, that's a... Oh, I should open up the schematic, but I think that's a diode. I believe I recognize it. I think that's just my regular 4007 diodes. Yep. Standard diode. And check. Alright, the main IC is the AP33772, which is that one there. That should be all I need for the mouse bag. Do know that I need one of these. Okay, so other parts I need are I know I'm gonna need 10K. That's 10K. This is 100 nanofarads. Yep, I see 1, 2. I'm gonna need 2 of those. Okay, I need those wheels, and then what else? 5.1K. Oh, that one. And that sense resistor is 10 mega ohms. Oh, NTC. Nope. Huh. Oh, that sucks, Aaron. Never understood that we can be such an advanced and smart species, yet relatively basic things that we could be doing as a society, we choose not to do, all in the name of capitalism and power for the individual. I think that's mind-bogglingly short-sighted. Like, if aliens were capable and out there, like, they always say, like, oh, they would come visit us. Well, if they had the capability to go interplanetary, which, as far as we can tell, we haven't, we've found planets that we feel could have life, but we haven't been able to prove that they do have life. So, if they're able to cover that distance and actually visit us, that means they've spent either a lot of time traveling, or a combination of not only a lot of time traveling, but a lot of time being able to travel that distance to build up their technology and whatnot, why would they want to visit somewhere where we can barely get ourselves to the moon, let alone Mars, and we're just, like, we're so wasteful. Like, we waste food by the boatload and then complain that there's countries that can't have food, or, oh, you shouldn't have thrown that away because someone could have had it. Like, we don't have a food production issue, we have a food distribution issue. It's like, just, yeah. It's so many things I feel like we could be doing differently, and it's a shame that we choose not to. We'd rather blame things on other people or other circumstances rather than actively doing something that could be better. Like, I don't ever expect stuff to be given to me, and I try to look for things, but when you reach a certain level of income, it's just stupid to always be expected to budget things and to always have issues with stuff. And the one thing I saw that I always I thought was good comparison. Oh, what was it called? Need the green LED. They pointed out people spend more time worrying about the dollar they're about to hand to a homeless person than the billions that rich people get in write-offs and so forth. What am I looking for? I got that. Oh, the 1UF. I still need that. Debatable. Like, look at 3D printing. For the longest time, they had patents protecting all of it. No, that's 5. This one's 10. Ah, cool. For the longest time, they had patents protecting all the 3D printing, but as soon as a lot of them started becoming open source, like, the innovation changes in the open source community just absolutely skyrocketed what the technology could do. That's the one. It's the same with resin 3D printing. The resin printing has come a long way too, for the same reason. Like, a lot of the technology had been held back for so darn long. Because it worked for the rich companies that could afford it, but that's all they needed. They didn't need to improve it to a certain degree. Ah, there's the 1UF. Yeah, I was saw not necessarily a documentary, but they were talking about what was it? A cruise ship. The engines are absolutely massive on them, but specifically they were talking about like the generators, not the main drive engines, but the generators for keeping things powered and whatnot. And one of the companies that maintains them and builds them managed to take like a 20 what do you call it? It was like a 20 to 40 piece assembly and 3D print it all in one piece. It made assembly easier, makes maintenance easier. They were actually able to make it more complex in its styling that made it more effective and more usable. It was just better. I'm actually going to leave those 10K pull-ups off because I have them on other boards. Yeah. Kind of want to leave them off, to be honest. And then still need the MOSFETs. And I need these tantalums. No. There are the MOSFETs. I'm in the camp now where eventually it's gonna collapse on itself, I think. I think we've kind of reached a point where there's so much polarizing opinions these days that no matter what, it's just gonna collapse on itself. And you kind of just have to wait till it does that before you might actually have a chance of fixing it. Still wonder where those diodes are. I think the diodes are part of that one order. Let's see. Let's see which order I put it in. That is yeah, okay. So it should be in this order. And then the only other part I'm looking for is, oh yeah, the tantalum capacitors. Yeah, see, I made a mistake when I was filtering the results for capacitors. So these are tantalum capacitors, but these are the larger ones than the ones I want for here. At least I think they are. Let me double check. I think these are the large ones. So I accidentally ordered 10 UF in 2 different sizes, but I wanted this large size to be 33. Not expecting too much difficulty when I put it on the other boards, to be honest, but it's just a silly mistake to not realize. Yeah, these are the large size. I want size down that I bought. The other one I'm looking for is 97. Oh, here it is. Are these protection diodes, and then maybe now it's those capacitors. Oh, here they are, hidden in the box. What do you know? That should be all the parts I need. Just think. Yes, 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 yes. I think I grabbed the... Yep, okay, I got everything. One thing I wanted to check. So I think I used an extra large footprint for this diode. I think the diode will still fit. Yeah, it still fits. Larger than what it needed to be, but I think it will still work. Yeah. That is definitely the wrong footprint. Whoops. But I think I can still solder it. What footprint is that? How did I pick such a wrong footprint? Oh. I know what footprint that is. Wow. Yeah, I really chose the wrong footprint for that. That's many sizes off. Whoops. I'll be able to make it work. Let's clean the spatula. Hopefully that didn't just screw up all the pads. Let's see how that turned out. Let's switch camera. This is the other thing I want to do. I want to build like buttons on the various different devices so that I could easily switch views instead of having to go and manually change it. No, I think this is the one. Yeah, there we go. So let's see how this turned out. Oh, that actually didn't turn out too bad. Oh, that turned out better than the last time. Ooh. I did put a little too much solder paste, but nothing that should affect it negatively. Now that is a little lopsided. What if I can move that? That should do that. Let's zoom out a little. Don't need to be that close. Let's check how that did. Yeah, that's fine. That'll work. Yeah. Oh, I need a red LED. Oh, let's find. Where in the world did it go? See that one? Where in the world did it go? Ah, there it is. Okay. Right. Oh, that's fine. See, I want it a little heavy on solder paste here. I think I'm kind of just gonna have to leave it and hope it flows and check it after. But everything else looks good, so let's start putting in parts. I think it's gonna make the most sense to place them using the microscope. That way people can see it better. You can see the discrepancy in my diode sizing. Let's try moving solder paste over so it has a better chance trying to solder. Obviously I can go back and fix it manually, but if I can get it to do it all on its own, why not? Now, 100 nanofats, I got two spots. Yeah. So, 100 nanofats. One. There's two. Let's put these diodes in place. these diodes directional? I think they are. Right. I see markings. I don't think I see any. Got a letter on it. Looks like it. Doesn't really help me. Let's see the pads. Oh, I can see something on that pad. Oh no, I dropped it. Gosh, this sucker's small. But that pad in the upper corner there has a bit of a chamfer, and that should be pad 1. Which looking at the schematic, pin 1. Okay. Potentially it's a transient voltage suppressor. It's a TVS diode. So I'm not entirely sure if a multimeter would actually show that. You know what? It can't hurt to find out. But if I go back, yeah, so that top one I think is pin 1. Let's see. Yeah, so this sucker is small. It's a QFN 1610. It is very small. I wonder if I can find measurements for it. It measures 1 millimeter by 1.6 millimeters. It is a very small. So let's put the multimeter into diode mode. Yeah, okay. Yeah, I was right. Yeah. It's a small one. So that needs to go right there. Come on. Stuck to my tweezers. Ooh. And there's one more that needs to be placed over here. And I need to figure out... I have that backwards in my hand right now. Actually, no, let me double check. I think that might actually be the right way around. Yeah, it is. Okay. Yeah, so I need to place that. Like this. Stuck to the tweezer again. There we go. Gotta fix this connector. Probably should have done it after. But that's that diode. Capacitors. Now, there's one. There's number 2. What else? Let's add the MOSFETs. Yeah. There's a dot right on that footprint, which is with that. Those MOSFETs. Zoom out a bit. Is that a 1K? Yeah, it is. Oh, okay. I'll have to go find that 1K in a moment. No need a 1 UF. I think I only need one. So let's put that in. that goes over here. And let's see what else. NTC. Um, 5.1K. 2 of these. That's in place, and just a few parts left. There's our sense resistor. Should be 10. Yep, 10. Right. LED. That's an LED without a marking. That is lovely. Why would you manufacture an LED without a marking? That is just ridiculous. Altimeter. Which way? Here. There we go. Eventually gets it in place. Should be able to probe that. Yep. Just right around. And 10K resistor. We got one, got two, okay. We got one spot up here. One there. Put one over right there. And so I got an LED that needs to go there. This LED thankfully has a marking on the bottom, so I know which way it needs to go. Yeah. That should do it. So the only thing left is that, and I need a 1K resistor there. Oh, and the USB connector. So I think that's all I need. So that resistor. And the only thing else would be right. Let's get the IC in place. This is, oh, it doesn't say. QFN if I'm not mistaken. Where is pin 1? Pin 1 is... So, we're looking at the QFN. Pin 1 is right there. So... looks like it'll work. That leaves USB connector. That looks a lot better than the last one I placed. In the oven it goes. Wow. So I plop it in the oven, and there goes my USB connector. Need to place it gently in the oven. I think the solder paste is starting to dry out, just because it took me so long to place all the parts. But I think it'll. I've had good success with this paste, so I think it'll flow fine. Okay. Switch to the overhead view. Did it? It did move just a teensy bit. But not enough that I'm worried about it. There. I nudged it slightly, but I think it would have flowed either way. Oh, I can't wait to get more of this project done. And working, obviously. I know the software is going to take me a while. The hard part is that I kind of have to make some of the software modular, especially like with barcode scanners, because I already know other people are interested, and obviously you don't want to have to rebill someone hours to reprogram it all just to meet their needs. So I'm hoping to take a page out of the Auxer's setup where it uses the dynamic JSON to set up like how the touch display works and how the admin UI works, and hoping I can kind of create a JSON config file that will let me set things up to work. But that's going to be a lot of work to implement, obviously, and my plan is to go visit the one company that's interested in the system as well, so that I could see kind of what they're thinking and understand it, so that I can try and pre-program it in a way. But obviously, when you're buying something custom, you're going to pay a little extra anyways if I have to reprogram it. But it's the bonus of going custom is that it will specifically meet your needs. But managed to get progress done on website stuff, which is nice. And then I have that Lenovo set up ready to go. It's just a matter of actually building an interface for it, which is essentially a website. But I don't have enough of the building blocks to really warrant starting to make that website yet. The main website I've been working on is like a donor website. So it's actually two sites. One will be forward-facing on the internet and on the nonprofit's website, because we have some donors that pre-fill out donation sheets, which is very helpful because it has all the information in it, what's in the donation. And so I'm setting that website up so that when you go to print out the pages on a printer, it automatically adds the QR code for the donor's information. That QR code is working. The second QR code, I haven't set it up to work yet, but it adds a dynamic form with buttons to add more line items. And the idea is those line items will combine into another QR code so that you can scan it, and then the screen will pop up knowing that it's a massive donation, and just have you go through and confirm that everything that was typed onto the form was indeed correct. So still requires some manual input, but be faster than you sitting on a computer having to retype out what's already written for you. And then the second website is hosted on an ESP on one of these screens, the W32 screens. And then there'd be a laptop in the front lobby, so when someone comes in, they can fill out their information. This would normally be handwritten on a card, but you want to make things less difficult, so instead you just type it in onto the website, click print, and that ESP will... I have a thermal printer on the way for testing, and hopefully that, like, I've already tested that the ESP can generate the QR code properly. It's just a matter of making sure it can print it to the thermal printer properly, and then that would follow the donation until it's actually logged, and then you just have to scan it, and now it knows who to attach the donation to. If there's ever a need for receipts or tax receipts, that kind of stuff. And it beats trying to read handwriting. And it can all be backed up on the server, so less chance of things accidentally being lost. And both of those sites are almost completely set up and ready to work. And they're set up so that they can all run independently with almost no external stuff. I think the one site uses jQuery, but everything else is internal. But the bigger one will be setting up the databases and then setting up the main website for staff where they can see what's available. But for the gift card system, you have to be able to make requests and you have to see what's there, and if a request is in place, then the code has to be unavailable to others, and then yeah. So that website, obviously you want a good user interface for it, and it has to look nice and it has to function well. You have to be able to separate gift code requests into batches, because the machine will print out a receipt, and typically when you're giving gift codes to a client, you have to have them sign off that they received it. So you have to be able to group codes for a person and then be able to do that multiple times over, so that you can put the request in, then it gets approved, you go over to the machine, scan your staff tag, and then it lets you dispense what you want to take at any given point in time, as long as it's approved, of course. And upwards of 1,000 codes a year getting processed, if not more. So I bought 1,000 blank codes from China, and they apparently weigh 5.7 kilos, according to UPS. So those should be delivered this week. The reader writer that I bought is an older version, so I actually have to use a Windows XP virtual machine to use the software for it. But the thing is absolutely massive. So like a regular code reader is like this size. The thing is like 10 times the size. It's absolutely massive. But it works. I got it working. So the plan is to try and get my hands on various types of gift codes, to see the type of data that they program them with. And that way I can make variations of the various codes, because obviously the machine needs unique code numbers. So I'll modify the data and then start programming a whole bunch of codes. And the machine will be set up to both do the magnetic stripe, but I'm going to pick up more label maker tape from my label maker and make barcodes, because some companies now are switching to using barcodes on their codes. Some still do both. Some are just barcodes, some are just magnetic stripe. Barcode, in my opinion, is easier and nicer. You don't have wearing out parts. So I do plan on, inside the machine, when you insert a code, I do plan on setting up, so I'm going to use something similar to this, but the one I have uses RS-232, which is easier to get the data from, because I haven't been able to get crap out of this USB running through a USB host shield. Won't interface with it properly. So RS-232 it is, and I've gotten that to work nicely. Well, through a UART connector. I got a module on the way for testing, but I'm going to set it up so that it's actually on a moving platform, so codes could go through, but because this has 1 million reads, which even at 1,000 codes a year, like, it should last a while, but to try and not wear out codes unnecessarily, or to wear out the reader, I plan on having it on like a servo so that it can move it out of the way, so that codes can move along the conveyor system, and then there'd be a barcode scanner pointed down that can read the thing. And that board's done. Let that one cool off, and I'll continue rambling. So yeah, that's the plan, at least, is to hopefully have a system. And then what I found online was from China. So obviously commercially have kiosks for like parking garages and whatnot that can dispense codes or whatever. Well, I found that raw assembly for a decent price. It was $125 US. Shipping was annoying. It was $70. So far I haven't gotten the customs for it yet, but we'll see how that goes. And while it's expensive for the one, the shipping for 10 of them is like, comes out to like $28 per one, which is ridiculous. That it drops from being $70 for one to being $28 for one. Do I really need 10? Probably not. I think they each hold like 100 cards. I think they hold 100 cards. 140 or something. They hold a decent number of cards. But for the price, I thought it was worth testing because it has the built-in motors, it has a control board. Just thinking. I want to see if I can pull it up on my computer. Let's see here. Let's see here. So, yeah, so this is what I bought. And so it includes the motors, includes the control board, and it includes this whole metal assembly. I like this one because it uses stepper motors. There are some that use brushed motors. This one looks like it's using steppers, and I hope it is. You can get them with like a front bezel on them and with redos and whatnot built into them, but I don't need a redo, so I just bought this one, which is the bare assembly. And so it's got this stacker on it, and you can extend these stackers too. And so it can take codes in, but it can take codes out. And if it detects an issue, it can actually drop codes into a lower section down here. And then the codes it's taking in, it automatically stacks them up. And it's supposed to be able to handle a code a second. And I figured for the price, it was worth testing to see if it works. Because if it does, then all I really have to do is create a network of conveyors and put like really tight spacing on sensors to know where a code is, and then blocks with servos so that you can stop a code from moving. But I figure as long as the database knows where code is in a stack, you should be able to move them around really quickly. And obviously, if a request is approved and the machine's setting idle, you could just have it start moving codes into like a secondary container, so that when somebody goes to collect, it's a lot faster to find that code. At least that's my hope. Trying to see if it says how many it holds. Yeah, so it holds 180 codes in each assembly. So, yeah. So I'm hoping it works, and then I can use it. And it all communicates with RS-232, so something I can relatively easily interface with. And I can learn from it with how it uses the rollers and whatnot to move codes. Now, I don't think I'm going to end up using rollers, except for maybe the section where it's running through the magnetic reader, because you want to maintain speed to read properly. I think most of what I'll end up building will be a conveyor belt, so like probably just use belts like you find in a 3D printer, or even the belts you see on this, just longer. But obviously I'd have to see about the code rolling over top of that or whatnot. I'm sure I can find something to work. I just think these roller wheels won't work as nice if you're trying to stop a code in its tracks, or like flip up either a solenoid. I don't want to use a solenoid just for power draw and circuit management, because you gotta watch the feedback on the solenoid, flyback voltage. But I'm thinking like a servo arm flipping up could stop a code, and then you could have like a platform pop up to push it into this machine. Yeah. It's gonna be fun to test, that's for sure. I think UPS has been fairly quick with stuff of late, so maybe I'll get it this week, if not next. Well, I think this board has had a chance to cool off. Oh, let's turn off that oven. Let's grab a microscope and see how we did. So the first big one would be... Oh, look at that. That's soldered like a beauty. Assuming that it actually soldered those pins. Could just float the solder nicely. Not actually solder the pins, but let's find out. Oh, I think it actually soldered it. Wow. That's nice. Wow, that worked. Woohoo! Hopefully my explanations of the project are making sense. I'm assuming that people are still watching and I wasn't just rambling. Thanks, Ed. But this is indeed the type of work I like to do. One-off and custom things, and well, I enjoy being able to switch between tasks, and I'm doing this for a non-profit that is near and dear to my heart, so it's nice to be able to help a cause. And considering I do volunteer hours and I help log some of these donations, being able to automate my own tasks is and get paid for it is kind of a cool thing. And I get to show off what I can do. Now, this QFN, how did it turn out? Ooh. No shorts. see any bridging. See, this is why I like QFNs. They seem to solder really nicely, but you look at something like the W5500 and I can't solder those anywhere near as nice as these. I can always get a QFN to solder like nobody's business. Yeah, that worked. It's got some flux on it, but it's fine. Those look like they're in place and they don't seem to be problematic. Yeah. There's one over here. Yeah. And that should be fine. Yep, no issues on that. The only thing to really test on this would be seeing if it actually powers up. Well, actually two things. I can power it up and I can try and see if the MCU board will recognize the I2C address on it. Let's see. So let's grab USB cable. Let's grab a quick cable. Use one from my stash for now, but I have more of these cables coming specifically for these boards. And I've ordered some probably overkill sized ones, but as I said, there's like 4 of these boards and you might end up building like a backer plate to hold them all nicely. So, right. USB into that, and let's reopen Arduino. Not entirely sure why I closed it. Yep. Okay, and then, so it's not showing anything for I2C devices, but let's see what happens if I plug this. So this is my phone charger, so I know it can do 5 volts and 9 volts. Let's see if anything happens. I don't think it's going to. I think it's going to be dormant until you tell it to do something. Yeah. Now I'd be curious if it expects 3.3 volts through this I2C line to power up, because I would kind of expect it to be alive right now, doing something at least. Actually, it might be alive. Might just not throw a warning or anything. Let's see. Really should get my UT61E set up. Actually, you know what? Let's do that. I have another USB cable. This is a good question. So I need more USB micro cables. Haha, I do. Awesome. Still need more of these micro cables. That's that. Let's fire up Node Red. And let's see. So it's gonna let me do this. Should be right. Let's see. Yeah, okay. So that works. I just need to know why it's not firing up. Ah, there we go. Swap out my multimeter leads. See, I want to get this stuff all mounted up so that I don't have to fiddle with it all the time. There we go. Okay, so let's see. Anything coming out of this? No. Nada. Anything coming in? Oh. It's not telling it to turn on. That's interesting. I'm curious, does it just attempt to do nothing, or does it blip for a moment and then shut down? Oh, I don't see it trying to do anything. So, what I'm gonna try then is I want to see. I have to fix this diode for one. And then I can bridge it out, and it would give it 3.3 volts from the control board. I'll jump that. Should now give it 3.3 volts. So let's power that down. Plug that in. And I'm gonna leave that USB undone. That powered up and nothing's smoking. So let's reopen the serial monitor. It's not finding anything, which is not a good sign. I would think one of these LEDs would light up and do something. Like even throw a warning. Let's look at the schematic. So GPI 4 is that one LED, and then where's the other one? The other one is a 5 volt, and it's coming from the actual IC's internal regulator. So if it was powering up, it should have a light. Because it's not doing anything. It's not a good sign. Did I get that soldered? This connector is moving more than I'd like. I need to put the solder on it some more. So I'd be worried that the QFN didn't solder right. Let's break that jumper. And I want to try using this 5 volts. Okay, so there is a problem. My computer flagged that as a power surge. So it flagged that as a power surge. So that tells me there might be something wrong with this QFN, with how I soldered it. So let's get the hot air out, and we'll remove that. Let's get the flux pen. Get some flux on it. And it's possible one of these connections got bridged underneath to the ground pad. What I'm gonna do is try to remove this, see if USB connects properly without saying there's a power surge, and then try and flow it back into place as needed. The quick connector on the controller. No, it's fine. Well, the quick connector is fine. I know the USB on the main board is wiggly, but the quick connectors are fine. Yeah, that USB won't go nowhere now. Let's just make sure there's no, yeah. Oh, the cable? It shouldn't affect the USB port. But yeah, I'll keep an eye on it. Go here and make sure we have no solder bridges. Looked like it was soldered fine. Yeah, looks okay. Oh, did my overhead camera freeze? Oh! Oh no! The overhead camera froze. It did indeed freeze. Let's try. I think that whole USB hub went out. I wonder if it's probably plugged into the same hub on my computer as my oh, what do you call it? That had the power surge when I plugged in. So it's probably reset the whole thing. Trying to get the USB cable on it. I am still here. Oh, hey, my audio still works. Cool. So let's see if I can get the overhead to work again. Hey, we're back. Okay, I got that working again. But, as you can see, I have managed to successfully remove this. Looks like it has some bridges on it. Does my... Oh, this froze too. There we go. That's back. Still working? Cool. Okay. Now, yeah, so that shouldn't have any bridges on it, and theoretically should be able to connect, and I shouldn't see anything because the IC isn't there. But with the multimeter, hopefully should be able to see power. What? Nada. What? I wonder if it's because of the resistors, because the resistors are going to auto-negotiate what it wants. And those resistors are really high. Sorry, really low. So it's not going to be your traditional 5-volt supply, because the IC is supposed to adjust as needed to account for it. Let's see if my computer freaks out about it again. My computer's not freaking out about it anymore. Well, that's a good sign. So does that mean my computer gave me 5 volts? No? That's weird. Is this USB port still working on my computer? No, it's not. Oh. Well, that's, annoying. It shouldn't have burned out that computer. Like, it should be auto-resetting. Why? Can I reset whatever malfunctioned in my... Hmm. It's not throwing any arrows. If I started power management. Well, does my phone charger at least turn on my phone, or has it gone into a save me mode? Oh, it's... Oh, wait. Oh, okay. No, my phone recognizes it still. So, yeah. I wonder if this diode is backwards. I'd be worried I got the diode backwards, but... Only thing I can think of would be to try and resolder the IC back in place and then try and desolder that diode. Also be wary of this capacitor. I don't know if the supplies are freaking out that trying to charge up a capacitor so much. Let's remove that for a moment. And let's try putting this IC back in place. Probably going to have to restart my computer to get that USB port back, which is annoying. Kind of want to put my soldering iron across these pads. I think that's in place properly. Be curious. Does it show a short? Well, front way around. It shows a short. Oh, there is a problem somewhere. So there is a problem. That's a problem. But where's the problem is a good question. Well, yeah. So, it won't power up because that is the problem. Well, let's remove the IC again, because that's your easiest culprit to test. One more flux. Now granted, it's possible that having the flux on us now is probably contributing to the short. But I can clean that flux fairly easily if I need to. But let's try removing some stuff first and see if we can't find why we have a dead short. Nope, we still have a dead short. Let's try removing our capacitor. Nope. Still shorting. Well, let's try removing a sense resistor. Because the sense resistor will pretty much isolate on that, everything on that side. So if it's something on the other side of that sense resistor that's causing a problem. Phoebus and ground. Oh, we still have a short. What? I'm at a loss. Sounds like I need to clean the board. Okay, cleaned all that flux off. Let's see if I still have a short. I do. How? Yeah, that's a complete short. Wow, okay. Is there manufacturing error with these boards? Let me pull out another board. Yeah, that'd be my next thought, but removing that USB port is gonna be an absolute pain. Because I soldered the tabs on it. Trying to think, which one? It's this board here. Let's double check that this board yeah, I will try that in a moment. Because I pretty much isolated everything else. So let's just double check that there's no erroneous connection in the design. Yeah, okay. So it is capable of being open. So there has to be an issue with the connector. And I think I can see it. Switch my view here. I think I can see the issue. Yeah, see that right there? Look at that. That sneaky little piece of can't speak. Solder. You can see that right there. That is right there. What a sneaky bugger. Yeah. Let's see if we can't get some flux on that and get that to work nicely. Nice and hidden under the connector too. Come on. There we go. I think that did it. I think that did it. Multimeter. Well, there's still a little bit. Let's try cleaning the flux off. Because there shouldn't be anything giving that a short right now. I'd expect it to be out of limits. I really hope that because it flagged a power surge, I'm really hoping that it just needs a reset. Once my stream's done, I'll do a reboot and hope that the port comes back. Because I think the port that it's connected to is my external hub. Well, it's a PCIe hub, but right now it's not allowing power. It's shut off, but I'm hoping that a reboot will allow it to work again. But we do know that my phone thing protected itself. Right. I'll shut one off now. Let's see. Still got a little bit of a short going. But it shouldn't. It really shouldn't. It's gotta be that connector still. There's gotta be a short with that connector still. I wonder if that's shorting on that end. I think the whole thing is being sneaky underneath, so I'm gonna try and run. See, I'm trying not to use the hot air on it because I don't want to warp the connector and the plastic on it, because this back section is all plastic. Yeah. That looks like it might have done something. Let's try. Oh, it's getting there. It's the best we've done so far. I wonder if I have a way of probing this connector. Should be able to probe ground and there. Oh, even that one's got a bit of a short going. Huh. Interesting. So it should be better then. But even this connector's got a bit of a short going. Wonder if it's enough that this will work. Like almost 200 mega ohms. Jeez. Let's look at it under the camera. I don't see anything. I think that's about as good as I'm going to get it. Let's try cleaning it some more. Just to see. Actually, let's use some low-level hot air just to dry it out. Oh, forgot to switch the camera view back. There we go. So I used hot air to kind of dry it out after I cleaned it again. Oh, that's worse. What? You know what? Let's see if it actually turns on. Because that's in the mega ohm range. Like, I'd expect that to be acceptable to a degree. Yeah, there we go. 4.9 volts. Woo! Okay, let's put some parts back in place and see if it turns on. Oh, I need to up my air temp back. Let's get the capacitor. There we go. Resistor. And let's get our QFN back in place. If I can find the marking on it. Okay, let that cool off. Actually, I can test and make sure we're not on a dead short again. Yep. Still wish that was higher, but should be enough to allow it to work. Okay, so that should hopefully power on. Ho ho ho! We got a green light! Ooh! That means all I need now is to double check that it can actually find it through I2C. I wonder if the USB ports reset itself yet. No? Really? How long does it take to reset itself? Is it really gonna require a full reset? Not mistaken, I got a second port down here. Ah, there we go. So the second port works, so it has protected the hub. So, yeah, okay, cool. Close that. Go back to Arduino. And then connect this. And then connect that. Okay, so that's powered. Set COM port, because it's now different. Open serial monitor. No, we're gonna get on the serial monitor yet. Why not? Let's try a reboot. It's probably holding up the bus. So let's try powering it. Expect it to throw an error by now. Ooh. It is finding it. It can find that IC. Oh. And it's even flashing an error code. What do you know? It's... So whatever it's currently programmed, it's outside of its program. I'm gonna need to buy a proper USB thing. I'll have to go to IKEA at some point. But it is finding it. It's address 0x51. I think I have a Sharpie here somewhere. Zero X 5-1. And I didn't really check, so I'm really hoping that these various devices all have different addresses. But that is awesome to see. I'm curious. Wow, my 4-hour music mix has come to an end. Whoops. Ooh. New subscriber as of 4 hours ago. Cool. Thank you. slowly gain some more subscribers. Eventually I can turn on AdSense. Woo! But I can't see my screen. There we go. Yeah, so it's still negotiating 5 volts, which is what I would expect. Like, I wouldn't expect them to be trying to pump out the voltage. I'm curious, does it, it's turned off right now. So it's not trying to output anything. Which you'd kind of expect, like, out of the box, why would you want it to start pumping out the voltage? And potentially ruin something until somebody has a chance to actually program the thing. That'd make for some interesting smoke if somebody was not prepared for it. Actually, I'm curious, because I have all these spots. So I should see voltage there, which I do. So that's after the sense resistor, but before the MOSFET. Between the FETs, nothing. Okay, so it's got both FETs turned off, which technically I believe the FETs are wired together, so they should both turn on at the same time anyways. So yeah, it shouldn't be showing anything until it's turned on. But that is cool. So that leaves, I want to try and get that diode back in, the protection diode, and I want to put the terminal block in place. Now the interesting thing with this is that if this is not powered, at least it looked like it in code, it was blocking this I2C line. So you'd probably want the ability to isolate the device if you're building it into something. Otherwise, you'd end up with a stuck bus. Now, I don't actually plan on using this in my production, just because I don't need USB PD to run my charging in my particular application, but it's kind of a complementary set of boards, so. See you later, Aaron. Thanks for keeping me company. Yeah, I'm just gonna finish these last few solder joints and then I'm gonna call it quits for the night. I hope I can get to the other 2 boards tomorrow, but I know there's some stuff going on, so maybe not tomorrow, maybe a few days after, but I will get to them because I need to start testing the code on these, making sure I can actually make them all work. But cheers, Aaron. Where did I put that? There it is. I cannot tell which way around that goes, so let's put it in diode mode. It's hard to get leads on this, oh my goodness. That's not working right. What in the world? Yeah, okay. Wait. Does that show anything? Yeah, okay. So, fairly certain it should be this way around. Yeah, okay. Yeah. So the way that goes in, that's in place, and the only other thing I need is terminal block. There we go. And let's just make sure that still powers up. Yep. Cool. That works. So, other than needing the battery placement item, holder, I should say, that is ready to go. That's 4 boards down. I'm hoping those holders are going to arrive in a day or two, actually. I think they just passed customs. The only thing left are the charger and battery management boards, and these ones are going to take a while. Cool. I think that's all for me. Still watching, Ben, or you moseyed along? That needs to be cleaned. That's done. That can be put away. That's turned off. That can be put away. And that can go over there. Right. Stay there. I can turn that off, that off, that off. Yeah, okay. That's everything. I'm gonna take some photos, post things online, reset my computer, and hope that I can recover that USB port, that I didn't burn something out. But, thanks for watching, folks. Oh, Steven, you're still here. Cool. Thanks for watching. Oh, and thanks for subscribing. I saw your subscription notification. Oh, and I'm realizing my microphone's still on.